If you're not already on scene 2B, open it now using the scenes folder to load BCCE scene 2B. And this is a good place to start the animation. Start by hiding the molecule that's in the scene right now. It's formic acid starter molecule. Highlight it in the hierarchy. Uncheck the box in the upper right-hand corner, and it is gone. So now bring in the reactant molecules into this blank scene. So that's assets, prefabs, Fischer essentials, reactant molecules. Formic acid protonated for me is the second one. Drag that into the hierarchy. Should say formic acid protonated, should look like this. Then center that molecule by setting its position to x equals 0, y equals 0, z equals 0. This will work even if you couldn't originally see the prefab. Second, you want methanol. Here's methanol, parentheses oxygen atom. Bring that into the scene. Again, adjust its position. X equals 0, y equals negative 2.5, z equals 0. So this is a pretty good reactive position for the methanol right below the sp2 carbon. Now make an empty game object. Game object, create empty. Rename that. I'll call it tetrahedral intermediate, productive. This is on the path to actual formation of ester. And make that position be 0, 0, 0. Okay. This is what we're going to animate. It needs to have both reactants inside it. So first, click, drag formic acid onto the tetrahedral intermediate. Now it's a child of. Same with the methanol. Click, drag on top of. And now there are two children. Beautiful. Happy family. We'll then unpack these child prefabs as we did earlier. So right click, prefab, unpack. Now highlight methanol, right click, prefab, unpack. So this will make the animated complex separated from the original prefabs. So I'll now expand the children. Click the gray triangle. Click the gray triangle again. So the top is the formic acid. It's protonated. Has 3 bonds. One is a double bond. And then there's the single bond to hydrogen and this single bond to OH group here. These will all need to rotate just like you did with the SN2 reaction. The methanol, if I expand that one, has a hidden bond. This straight up bond doesn't exist or is invisible right now, but it will have to become visible. Then there's another lone pair which is going to remain invisible. There's the hydrogen attached to the oxygen, and there's a methyl group attached to the oxygen. There's also a hidden formal positive marker. I'll show it by highlighting the game object and then clicking the box on the right, and you can see that is already built into the prefab. Just about ready to animate this. Select tetrahedral intermediate productive. Animation window at the bottom. Click create. It'll come up as new animation. Find the assets animations folder. Something that looks like it works, right? Productive attack, maybe. And save that. Okay, everything's blank at the bottom. but we're ready to do the changes that result in a tetrahedral intermediate. Yay. I'll start with the methanol, the nucleophile. Click the record button. Drag it out to 50. And simply type in for the Y position, negative 1.5. There's the approach to the nucleophile. The other thing that needs to happen is we need to make a bond between the carbon and the oxygen. Expand bond rotatable straight up. Should see a bond stick inside. It is right now invisible. It's inside the oxygen atom, but we'll make it come out. Make sure your timeline marker is set to 50, and we'll set the size of the bond, the scale of the bond, Y scale to be 0.5, and the position of the bond, Y 0.75. And there you can see there's a bond. So now this is the approach of the nucleophile. Beautiful. Before we leave this, let's make the formal positive appear. So timeline marker on 50. Formal positive marker, set it active. Okay. Part of the animation now is the formal positive appears. Okay, the methanol part is done. For simplicity, I will close up the methanol, focus on the formic acid, protonated. There's a double bond to oxygen, bond to hydrogen, bond to OH group. Those all have to rotate. They're all rotatable bonds. Start with double bond to oxygen. And you can see the Z rotation is 90. It's 90 degrees from the top. Make sure your time marker is at 50 frames. Make that 70.5. And you can see that it tilts up. Same for the other two. You can actually do them both together. So I highlighted both. And timeline marker at 50. 70.5 degrees. Okay, let's take a look at that. Everything's great. Need to make this formal positive disappear. And need to make this double bond disappear so we don't have a Texas carbon with 5 bonds. Okay, so double bond to oxygen, expand that. There are 2 bond sticks inside. So make sure timeline marker set to 50. Bond stick. This one, the position of the Y coordinate of position is 0.75. We want to push it into the oxygen. So this is relative to carbon, 1.5. Okay, so you can see it's the back bond there. And there it's lined up with the oxygen, but it's too big. So make the Y scale of that bond 0.2. Okay, so that will make that one disappear. The other one, you can see it's a little off center here. We can center it. Looks like all you need to do is set Z to be 0. And now it's centered. The formal positive on this top oxygen should go away. So that will be here in the hierarchy under oxygen, formal charge marker. Here we'll do it a little differently. Instead of just saying poof, it's gone, we can make it gradually change. So it starts here with a X scale of 0.12, Y 1.12, Z doesn't really matter because it's two-dimensional. And then by the time it gets to here, it should have disappeared. So formal charge marker is highlighted, timeline markers at 50, X 0, Y 0, Z doesn't matter. Okay, so now that should be it. There it is. New bond forms. Formal positive on the top, oxygen goes away. Formal positive on the bottom, oxygen appears. So you can do the same thing with this bottom formal positive, have it gradually appear if you prefer that. Change the scale from 0 to positive 0.12. Okay, this is done. Unclick the record button. Click Animator tab. Highlight tetrahedral intermediate productive. Orange box is where it all happens. Speed. Set the speed to 0.25 to slow it down by a factor of 4. And double click that orange box to take off the loop. Okay. Click play and you should see the reaction animation. There's the tetrahedral intermediate that could lead to product. Once you're satisfied with this, press stop and we'll proceed. To save your work, click the project tab at the bottom. Fischer is prefabs, Fischer Essentials. This is the folder I'm using to store these animations, transition states. Highlight your tetrahedral intermediate productive, drag it into the transition states folder. It's now ready for use whenever you want to use it. We need to restore this scene to its original configuration. So what's on the screen right now for me and probably for you is this tetrahedral intermediate productive that you just animated. So highlight that and uncheck the box in the upper right. So now highlight formic acid starter molecule and activate that by checking the box in the upper right. Now it's ready to go. We need to do one more thing, which is to activate the trigger. So expand formic acid starter molecule, expand carbon sp2 to sp3. At the bottom of the list is nucleophile trigger point. So highlight that and click the box to activate it. What you need to do is see on the right, there's a nucleophile trigger script. And it needs an animated transition state. So that's what you just made. So prefabs, Fischer Essentials, transition states should be the tetrahedral intermediate productive. So go back to here, re-highlight nucleophile trigger point, and drag in the transition state you just animated. And that should be it. It should now work. Okay, go back to game view if you need to. Press play. Click the button to bring in methanol. Imagine it hitting the trigger on that carbon. And that's all the animation that you made right there. Next up, proton transfer.